so this week we're going to take a look at section 9.1. We'll do a little bit of 9.2, and then we're going to skip the rest of chapter 9, and we're going to look at section 10.1. So 9.1 looks at what we call parametric graphs. So if let's see, I can show you some other ones actually, just doing them live. Well, there's one right there. So that's a spiral. It's one revolution of a spiral. We could also let's do something like this. Let's do just 3x and t squared. So some shapes we get, they just look like regular shapes that we've seen before, line segments. They don't always go on forever. Usually these kind of graphs, they'll start somewhere and they'll stop somewhere. A graph like this has probably the same start point and end point. So you can't really tell where it started from. The only way to tell where it started drawing would be to watch it as this was being drawn. And then it probably traced out some path until it got back where it started. There's another type of graph that we could draw. It's kind of like a butterfly kind of graph. It's a little bit fancier than what we get into, but just showing you some of the kinds of equations you can do. And there's one a little bit simpler. It's kind of just more like a wave that goes back and forth. We don't really get into any real complicated graphs. We'll do like a circle, a few other little graphs, but nothing as complicated like as that butterfly one. But notice all these graphs fail the vertical line test, which means you can't draw these in the mode that we've been using all year, because that mode is called, if we go to mode, it's called function. And function means that something passes the vertical line test. Now, you can kind of cheat and draw some things that fail the vertical line test in function mode if you do it as separate pictures. So you can kind of do a circle in function mode if you draw the top half and then you draw the bottom half as a separate one. So some things we can kind of do. But graphs like this would be way too complicated to draw as functions. So what is parametric? Well, the main idea of parametric, if you go to mode and then go to the second one over, it says parametric. If you put it on parametric and then press y equals, you'll notice it looks very different. It doesn't say y equals anymore. Well, some of them say y equals, but some of them also say x equals. And you'll notice that for any one equation or any one graph, like look at the blue one, there are two formulas to create that one picture. And that's really the idea of parametric. To create a picture, we're going to use two formulas. And what ends up happening is we're going to use one formula for the x values, and then we pick a different formula for the y values. So that's totally different than how we do like function notation. We use one formula for the whole graph. This is going to use one for the x's and one for the y's. And we're going to call the two functions that we use, I'm just going to name them f and g. And what we do to generate a parametric curve is we take those two formulas, the ones that generating the x values and the one that generates the y values, and we plug numbers into the formula. What numbers we plug in, they'll tell us what numbers we are allowed to plug in. Usually the way they tell you what numbers to plug in is they give you a minimum and they give you a maximum. And they say these are the numbers you are allowed to plug in to the two formulas to make your picture. So let me just skip ahead and show you one right here. So this particular problem is giving you two formulas, and you're going to plug in a value and I'll talk about what t is in a minute, but you're allowed to plug in numbers for t. The only numbers you are allowed to use are numbers between 0 and 1. So if you wanted to draw a picture of this, you'd probably start with 0, plug it into both formulas. The top formula is going to give you an x. The bottom formula is going to give you a y. You put the two together, now you have a coordinate. And then you do it a couple more times. So maybe you want to use like 0.5. Plug it into both, and you'll get another coordinate. And then we'll do the last one. Plug in 1, and then we'll get another coordinate. And then we'll draw through all those points. But you can only pick points between 0 and 1. What happens if you go beyond 1? Well, you don't get an error. It's not like you'll end up dividing by 0, something like that. It's just they don't want you to go beyond 1. That's where they want you to stop. Okay, and we'll go through and we'll do that. So if you take all the points, of course we only graph as many as we need to make the picture, but if you were to graph every possible point you could by plugging in all the values you are allowed to for t, that creates what we call a parametric curve. Even if it comes out straight, they still call it a parametric curve. And the two formulas that you use, the x formula and the y formula, those are called parametric equations. And they always come in pairs. If you have an x formula but no y, that's no good. You can't do that. Parametric equations always come together as a pair. And you'll notice here and here, I'm using the letter t. Well, t is the variable that we use. When we do like y equals, say a simple line, y equals mx plus b, x is the name of the variable you use. Well, in parametric, t is the name of the variable. So normally, when I press this button right here to the right of the green one, what would come up when I press that button? Yeah. Normally we would get an x. But if you looked at it all year, it has 4 things on it. It has an x, a t, a theta, and an n. Which letter comes up depends on which one of these 4 modes you're in. X, t, theta, n. So we're in parametric. So when I press that button, it's going to give me a t now instead of an x. So t is just the name of the variable we use when we do things parametrically. And it is a variable, but the term that they really use to describe it is it's called a parameter. It's exactly the same thing as a variable. So the parameter is part of what controls how your graph is going to look. When you do a problem, they will always give you a minimum value and a maximum value for the parameter. Unless they say it's all real numbers. But generally, they'll say, here's the smallest value you can use in your formulas for x and y. Here's the biggest value you can use for x and y. And we don't really do a lot of graphing by hand. Graphing parametrically by hand can be a little hard, especially if you're not used to parametric equations. But we do a lot on the calculator. So we're going to be using the calculator, and when you go to Window, you're going to see some new options that weren't there before. You still have your x mins, maxes, y mins, maxes. You got all that stuff. But now you have 3 new things, all related to the parameters: a minimum, a maximum, and a step. So we'll talk about what all 3 of those things do. But there are 3 things you need to set before you draw a picture. So parametric curves in general do not go on forever. Like if you draw a spiral, like that, I would say this point was the start point. and this point was the stop point. If I draw a line segment, this was the start point, that was the stop point. Even if I draw a circle, even though the start point and the stop point are different, it still has a start point and a stop point. They're just the same point. So that's part of what we need to figure out when we draw one of these curves. Where does it start and where does it stop? But just because you know where it starts and stops, that doesn't necessarily tell you how to get from the start to the stop. Because if I just gave you these 2 points, like this, I mean, you have no idea that that was a spiral. Right? You can't really tell just because you know where it starts and stops. So finding where it starts and stops is good, but we still need to kind of look at the original problem and look at the formula, and that'll tell us how to get from the start to the stop. So what controls where it's going to start and stop? Well, that's this. It's the domain that they give you for your parameter, the minimum and the maximum. Those 2 numbers control where the graph is going to start and stop. So I'm not going to do it specific with numbers for this, but let's just say you have a number here and a number here. We're going to do 0 and 1 in our next problem. If you want to find where it starts and stops, there's 4 calculations you need to do. You need to find starting x value and starting y. You need to find the ending x and the ending y. Those are the 4. A controls where it's going to start, and B controls where it's going to stop. So if you want to figure out where your graph is going to start, you're going to take the number they give you for A, which is going to be the minimum, and you're going to plug that number in to the x formula and the y formula. So you take that number and you plug it into the x and the y formula. And that's how you get the coordinate of where it starts. If you want to figure out where it's going to stop, well, pretty much do the same thing. You just plug in a different number. Plug in the maximum value. That's the b. Plug b in to the x formula, and then plug b in to the y formula. And that tells you where your graph is going to stop. Now, depending on what kind of graph you're drawing, if you're doing a line segment, start and stop is plenty. Disconnect the 2 and you're done. But if you have any kind of curve, you're going to need more information between the 2 points. And the more information you have for a curve, the better it's going to look. So things that end up being like straight lines, those are the easiest to draw. Things that curve get a little harder. Okay, let's look at this one. So here are our 2 parametric equations. They always have to come in pairs. The top formula is the one that's going to give you x values, and the bottom formula is going to give you a y value. And t is the number you're going to plug in to each of these formulas. And what does it say here you are allowed to use for t? What's the restriction on t? It has to be what? Yeah.
Between 0 and 1.
It's got to be between 0 and 1. You can include 0 and you can include 1. But it has to be between 0 and 1. So what that means is it's going to give us a pretty small graph. We're not allowed to use values that go beyond 0 and 1. So my x's and y's are not going to get that big here. They're going to stay pretty small. Okay, so let's find the endpoints of this curve. We'll do it by hand, and then we'll sketch it on on the calculator. Okay, what value here is going to control where this graph starts? Yeah? Which is 0. So 0 is going to control where it starts. So we're going to take 0 and we're going to plug it in to each formula. And that's going to give me the coordinate of the start point. So to find the start point, take 0, plug it into the x formula, and then take 0 and plug it into the y formula. Don't worry about the 1. The 1 doesn't have anything to do with where it starts. Let's do that out and see what we get. Quinn, if I plug 0 in for x, if I plug 0 into the x formula for t, what would that give me up here?
You're just going to end up with 1.
You're just going to end up with 1 because you'd end up with 1 minus 0. So it's going to start at 0, comma. And Manny, what if I plug 0 in for t in the y formula?
You would get it
2. So this graph starts at 0, comma 2. And where does it end? Caleb, what number is going to control the end point?
1.
The 1. Okay. So we're going to take the 1 and we're going to plug that in to the x formula. And then we're going to take 1 and plug it into the y formula. So Eileen, if I plug 1 in for t in the x formula, what will I get? Yeah, plug in 1 for t right here, and then simplify. Yep, negative 1. Perfect. So 1 minus 2 is negative 1. Right, and now we're going to plug 1 in to the y formula. So Sam, what do you get when you plug 1 in for t in the y formula?
3.
You get well.
Oh no. Wouldn't it be just 1?
Just 1, yeah. So 2 minus 1 is going to give you 1. All right, so negative 1, 1. All right, any questions on that?
Yeah, is she negative 1?
Negative 1? So we plugged in 1 for t, and we had 1 minus 2, which gives me negative 1. All right, now let's draw that on the calculator and see what it looks like. Okay, so first thing you got to do is make sure you are in parametric. Okay, which I am already in parametric. It doesn't tell you the mode you're in when you're not on this screen. You can't tell. So make sure you're in parametric. Nothing else up here matters. My calculator could say different things than yours. We're not typing in sines and cosines right now, so degrees and radians doesn't matter. Okay. When you press y equals, you should see a screen like that. If anything's there, you can just clear it. All right, so now type in both equations. 1 minus 2, and remember now when you press the button that it has the x on it, it's going to give you a t instead. And 2 minus t. Now, we know where it starts and stops. So it's going to start at 0, 2, and it's going to stop at negative 1, 1. Now, just because you know where something starts and stops, that's not a guarantee that it always stays between those values. Because what if it did something like this? I mean, that's going way beyond, well, this is 0, this is negative 1. It's going way beyond 0 and negative 1 because of the way it curves. But that's at least a good starting point for your window, because we know we'll see something. If it goes off the screen, we'll have to adjust it. So let's set our x, I would say set the x max to 1 and set the x min to -2. Okay, that'll give you a little extra. So let's go to window. Let's set the x min at -2 and the x max at +1. Now for my y, min and max. We have a value at 2 and we have a value at 1. So we know it's going to go between 1 and 2. Does it go beyond 1 and 2? Well, if it curves like this, it does. It's going to go way beyond 1 and 2. But at least if we set 1 to 2, we'll start to see something. In best case scenario, it's just a simple line segment, and then it doesn't go beyond those values at all. So let's do, let's say for y max, let's do 3. And for y min, let's do 0. So I did a little bit of extra. I did 1 extra unit, as long as I didn't mess that up on every axis. All right, now we need to set this t min, t max, and t step. Well, they tell me t min and max. 0 and 1. This is t min. And this is t max. So let's put those in. 0 to 1. Now, this other thing that becomes very important is the t step. That would be an awful t step for this problem, and you'll hopefully know why in just a minute. Yes?
How do you get it into parametric?
You just press mode and then go to parametric.
I don't have that.
You don't have parametric under mode?
Would it just say, is it next to function? Is it under par?
Oh, yours it says par.
I think so. That's
Oh.
what that means.
Yes.
Yeah. Never mind.
Okay, so t-step. What t-step controls is how many points are going to be graphed when you do this picture. So let's say we set a t-step of 0.1. This is what would happen. The calculator is going to start at the minimum. It's going to go all the way to the maximum. And it's going to add 0.1 every time to t, and then graph that value. So you would start by plugging you'd start with 0. Start with the minimum. You'd plug 0 into each formula, and you'd get a point. That's the point you would get. Then you would plug 0.1 into each formula and get a point. Then 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. You get 0.9, and then the last point you would get is 1, because that's where you stop. So the step controls how many points you're graphing between the minimum and the maximum. Now, if you set the t-step too small, like let's say I did the t-step, don't do this, but if I did 0.001, that's going to take way too long. Because now the calculator is going to start at 0, it's going to go to 1, and it's going to increment what it graphs by 0.001. So if I hit graph, it's probably just going to freeze. Well, actually, it's doing it okay. It's still taking way too long for this graph. And if you had anything more complicated than a line, the calculation would take forever. I don't know why I'm right on the edge of the screen. I thought I set my window to be a little bigger all the way around. So my x max should have been 1.
Why did I get this?
I'm just going to double check what I typed in. I might have typed in the wrong formulas. 1 minus 2t and 2 minus t. 1 minus 2t and 2 minus t. Okay. X max. Let's put it on 2. Well, anyway, there we go. There's the picture. So the idea is to try to set the t-step so that you get enough points to make a good picture, but you don't graph hundreds of thousands of points. All right. So I can't say to always what to set your t-step at. It depends on what your interval is. If you were going from like 0 to 500,000, That's a huge interval for t. I would not go by 0.1s. If you go by 0.1 and you count from 0 to 500,000, that's going to end up giving you 5,000,001 points, roughly. That's too many. If I had to go from 0 to 500,000, what's a reasonable number to count by? I don't know, maybe hundreds, 100, 200, 300. So that would end up giving me 5,000 points. Even that could be a lot. But that's what t-step controls. It controls how often the calculator is plugging a number into the formula to get your graph. Now, yeah.
What did you fix your graph?
I just set my x max at 2. Now, let's say we get a t-step of 0.3 in this problem. Here's the numbers the calculator would plug into the formulas to give you points. What's the first number that it would always plug in? Because this is the t-min in this problem. Yep. 0. What's the next value that it would plug in for t if it's going to step in increments of 0.3? Yep. 0.3. Aiden, what would be the next number that it would plug in for t? 0.6. Brighten the next number.
7, I don't know.
So it's stepping in increments of 0.3.
0.9.
0.9. Now, Alex, what would be the next one that it would want to try to plug in? Well, look at our increments. Look at what we're stepping by. What is it? 0. So 0.12 would have been like back here. That wouldn't be one it would plug in. What would come after 0.9 if we're stepping in increments of 0.3? 1.2. Now, T max is 1. You can't do 1.2. So what's going to happen here is you're not going to get a full picture of your graph because your last value that you could plug in for T was 0.9. You're going to have a gap between 0.9 and 1. So you don't want to pick a T step that doesn't land at the T max. So I would say, like, if you step by 0.2 here, that would be okay, because you'd have 0, 0.2, 0.4, 0.6, 0.8, and then 1. So that'd give you 6 points. But you generally want to pick a T step that lands at the T max. What that means is it divides into it without a remainder. Okay. And that becomes more important with curves. Because what's going to happen is the way parametric works is it just plots points and then it connects them in a straight line. So let's say you had a curve like that. If you graph thousands of points to make that curve, it's probably going to look pretty good because you're going to get a lot of points. Let's say you only graph like 6 points. It would put one here, 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 and then maybe at the end. If all you graph is 6 points to make that picture, it's going to look like this. So move it down. You can see that it has the curve, but it almost looks like it's made up of line segments. So if you don't put enough points, then things that are supposed to look curved are going to look more blocky, right? Because you didn't put enough points to get a nice picture. Right, so when we start to do circles, I'll show you that. We'll draw a circle with only like 5 points. We'll see what it looks like. And then we'll put in more points and it'll look better. Okay, any question on how we found the start, end point, or how we typed this in on the calculator? And it is a line segment. Okay, it's a straight line between the 2 points. So in theory, you could get away with just having the start point and the end point, and that's it. But I would say stepping in increments of 0.01, that's pretty good. That'll give you 101 points. Because if you count from 0 to 1 going by hundredths, you get 101 starting at 0. Now, sometimes what we can do is we can take an equation that has t in it and we can get rid of it. What this basically means is we're converting it back to the kind of formula that we're used to using. Y equals, and if it was like a line segment, it would be mx plus b. So we're going to take the example we just did, and we are going to eliminate the parameter and convert it back to function notation. And this one will work very nice to convert because it is a function. It does not fail the vertical line test. So when you eliminate the parameter, that means you are no longer allowed to have a t in your formula. You are allowed x's, and you are allowed y's, and no t's. So essentially what we're going to do is we're going to take these two separate formulas, and we're going to combine them into one. And I'll give you a hint at how we do it. We need to substitute in something for that t. You always want to substitute in for the t that's in the y formula. How could I get something to substitute in for t here? Anyone have a guess? Something I could do to somehow get an expression that I could plug in for t, that I could substitute in for t. Yeah?
Put the x, so 1 minus 2t, and 2 minus t.
Okay, so what do you want to do? Let's do something with this 1 minus 2t. What do you want to do with that? Need to rearrange it.
Subtract 1 from both sides and divide by -2.
Okay, you can subtract 1 from both sides, and you'd have this. And then what did you say to do?
Divide by -2.
All right, and if we divide by -2, I'm going to do each one of them separate. So when you divide x by -2, that's really like negative 1/2 x. X divided by -2, negative 1/2 x, same thing. And what's -1 divided by -2? About even? 0.5, positive or negative? Positive. Let's just leave it as positive 1/2. So that's what you get if you get t by itself in the x equation. Now, what do you think we're going to do with that?
Substitute in the y equation.
Yeah, substitute it in for t in the y equation. That's how you eliminate the parameter. You solve the x equation for t, and then you substitute that into the y equation, and that's going to take the two formulas and combine them back together. So we would get y equals 2 minus, and now fill in t, negative 1/2 x plus 1/2. And we're going to simplify that as much as we can. We know it's a line segment, so we're going to write our answer in y equals mx plus b. Okay, when I simplify that, what's going to be my slope? Well, Lucas, what's going to be my slope?
For the y.
Yeah.
Just function.
1/2 x, so we're going to get that for the slope. And what about my y-intercept? What's going to be my y-intercept there? Yeah.
It's going to be negative 2.5.
No, not negative 2.5. Well, Jazara, do you know what it's going to be? What property do we have to use with this minus in front?
So
Yeah,
Distributed.
distributive. Okay, so that's how we got the 1/2 x. But now the y-intercept would be 2 minus 1/2. Yeah,
so 1.5.
1.5, or you could say 1.5, or you could say 3/2. That is how we eliminate parameter from the problem we just did. So let's look at that. Let's take this. Not that. Okay, so here's our sketch. And now let's type in the equation we just had. So that's a function. So I need to go back to function. Put it in function. Now what's important when we do this is that the window stays the same. But the nice thing is if you set your x min, y min, x max, and y max, it carries over no matter what mode you put the calculator in. So those should all stay the same. Okay, and our equation was 0.5x plus, I'm just doing decimals because that's easier for me to type in on fractions. Okay, so that's what we got. Let's see if it looks the same. So does the one that I did in parametric look the same as the one I did in function?
The function continues seemingly forever, and the parametric is only enclosed like a certain from 1 to -1, it looks like.
Yeah, so the parametric starts and stops somewhere. So part of converting something from parametric to function is not only finding the formula that gives you the picture, but you have to tell me where to start and stop. Well, we know where to start and stop because this is example 1. And the way you specify the start and the stop is by looking at that's why. That's a 1. Because when you plug in 0 for x, when you plug in 0 for t, 2 minus 0 is 0, 1 minus 0 is 1. Did anybody recognize that? Oh.
I was thinking about I'm sure I'm wrong. So.
Yeah, no, that's I was wondering why my window was off. That's the reason. That was supposed to be a 1. So Lauren said it looks like the graph goes from -1 to 1 in parametric, and we can confirm it. That's exactly what it goes between, because we know the x value of where it starts, and we know the x value of where it stops. So when you convert the last problem to a function, you need to tell me start at -1 and stop at +1. So in addition here, we're just going to add that x is not allowed to go past 1, and it's not allowed to go past -1. How would you figure out the -1 and 1? You'd have to do what we did on the first formula. Find the start and find the stop. And that's what it has to stay between. So now, let's sketch that again, but tell the calculator where to start and stop. And the way I tell the calculator where to start and stop is in parentheses. I have to put the condition for x. I want x to be greater than or equal to -1. So you put in x, and then you press second math. That's where all your inequality symbols are. 4. And I have another condition. I want it to be bigger than -1, but then I also want it to stay smaller than 1. So put in x is less than or equal to 1. So in parentheses, x, second, math, option 6. Don't think you can type it in as a conjunction like that. I might have tried in the past. Maybe you can now. But I've always typed it in as 2 separate conditions. Now the calculator is going to do the best it can to try to draw something that starts at -1 and stops at +1. It's still not going to be perfect, but that's as good as I can do. And you can't really tell here, but it actually is drawing on the axis, because the calculator wants to draw everywhere. So it puts these little marks in down here, but that's the best I can do. So now, there's my graph as a function, but I've told it to start and stop somewhere. So that's the 2 things you need to do when you convert parametric to function. Find the formula and tell me where to start and stop. Let's try another one where we eliminate the parameter. Yeah, let's try this one. Okay, so first thing we need to do is pick an equation that we're going to solve for t. Okay, which equation did I say you always want to solve for t? Yeah?
Why?
Is that what we did on this one?
For x,
Yeah.
let's plug it into y.
You want to plug into y, so you want to solve the x equation for t. How would we solve for t? How about, Ashley, how would I solve for t here? In the x equation.
Not too sure.
All right, read me the x equation.
T minus 1.
X equals t minus 1, yeah. So how would you, what's preventing the t from being by itself?
The 1.
Mm-hmm. So how would you move
You'd
that?
have to add the 1 to the other side.
Add the 1 to the other side. So when I do that, Matt, what would t equal?
T equals x plus 1.
X plus 1. There we go. So now we've got a formula for t. And Jalen, what am I going to do with that x plus 1? Yeah, where are you going to substitute it?
T minus 1.
In this equation?
Oh yeah, the other one.
The other one.
Yeah.
And can you tell me where you're going to put it in this one?
You would replace the t with the whole equation.
Replace the t with
X plus 1.
x plus 1. So you solve for t in the x equation, and then you substitute it in for the t and the y. So this is going to turn into y equals, yeah,
In parentheses, x plus 1 squared.
yeah. There you go. So there's the formula that's going to generate the picture. But did the original problem have a start and a stop? Wyatt, did the original problem start and stop somewhere? Yeah, it did. It had a limit on the parameter. So we need to know the x value of where it started and where it stopped. And that's going to tell me what limits to set on this picture. Now, The limit here is not 0 to 3. That's the limit on the parameter. We need to know what happens to the x when you plug in the 0 and the 3. So let's start with 0. If we plug 0 in for t in the x equation, Casey, what do I get?
You just do like x squared plus 1 for the final.
So we're plugging 0 in
Oh,
for t in the x equation.
oh, so it'd be negative.
All right. So we know the smallest, well, we're going to get a value of -1. I don't care about the y, because when you give a limit on a graph, you never give it with y. You only are concerned about the x. And now I need to know the biggest x value that I'm going to hit. What do I get if I plug a 3 in for t in the x equation? 2. So I know that this graph is going to have a starting x value of -1 and an ending x value of 2. What's the starting and ending for the y? I don't really care. That's not something I need to know. But I know I start at -1 and I stop at 2. So there's the formula that's going to generate the picture, and that's the restriction where you're allowed to draw it. So this is going to look like a parabola, shifted left 1 unit, but you're only going to be drawing part of it. So it might look something like that. It's not going to be the whole parabola. Questions on that?
So the start and end point is the same as like the not the domain, but the range in which the limits. That's the same as the start and end point.
Yeah, you're basically finding the limits of what x is between. And again, this could be thrown off a little bit if the graph was more complicated and it did something like this. Well, now knowing the start and the end really has nothing to do with the limits of the x value, because it goes way beyond the start and the end. We're going to be focusing on graphs that are simple, okay? And if you know the start and you know the end, those values will be what you want to put right there. Yeah.
So how did you get -1 and 2?
So we plugged in the 0 and the 3 for t in that equation.
Okay.
If you wanted to know how high and low something goes, you could look at the y's, but we don't care about y values when you're giving someone a restriction. All you care about is x's. So that's all we did. And if it really is a parabola, which yeah, this one is, knowing the y value it starts at and the y value it stops at doesn't really tell you how high and low it goes. Okay? Not if it, let's move this off to the side. Not if it looks like that, because it ends up dipping below the starting y value. So you'd have a little bit more work to do if you wanted to figure out how low does it actually go. You'd have to graph it on the calculator screen and find the minimum, because it dips below the start. But if it does, and I think it does look like that, the maximum y value is the maximum. It doesn't go above the ending y value. Okay. Any question on eliminating the parameter there? Yeah.
What does I represent?
What does I represent? Oh, I. It's just the interval. It just stands for interval.
Okay.
It's the name of the thing that tells you the low and the high value for t. Okay. Right. Let's see if we can figure out how to draw a circle. So we're going to find the equation of a circle. Now, finding the equation of a circle starts by just finding a single point on the circle. And if you can find one point, then you can find thousands of points. We just have to know how to find one. So let's say we had this point. And you wanted to describe the location of that point as a horizontal distance from the origin and a vertical distance, because that's what parametric is. So we need an equation that's going to tell us how far right to go, and then another equation that tells us how far up. What shape do you think we could make in that circle that would help us to figure that out? Yeah?
Triangle.
Yeah, I'm going to make a triangle. And the way we're going to make a triangle is like this. I wanted to be able to show you. We need a formula that's going to calculate that form and tell me how far left and right to go. And then I need a formula that's going to calculate that, which tells me how far up to go. And where this point is going to be controlled by two things. First, it's going to be controlled by how big of a circle you are. What do we generally use to describe, or what would you tell somebody if you wanted to describe how big of a circle you have? You could tell them the what of your circle. Yep.
Diameter.
You could say the diameter, or something that I already have drawn in that picture. Yeah?
The radius.
I already have the radius drawn. So the radius is going to affect where that point ends up. And what else would affect where that point ends up? Besides just the radius of the circle. Something else in this triangle. Something else I could change besides the hypotenuse. And it would affect where that point ends up. Yeah?
The x and y values.
Well, the x and y would be affected by the thing I'm going to change. Yeah?
There's a 90. It's a right triangle.
So this is a right triangle, yeah. It's always going to be a right triangle. So what else could I change in that triangle that would affect where that point goes? Yeah?
Circumference.
That's your radius. Well, so your circumference would get bigger as your radius gets bigger. But something else about the triangle. About the triangle, not the circle. Triangle. Well, what's different about this triangle? That's another point we could find on the circle. Still has the same hypotenuse as the other triangle, same radius, but there's something different about it. Yeah?
The angles in the triangle.
Angle, exactly. If you change that angle, which I'm going to call t. Now, I know I normally use a Greek letter for an angle, but we're doing parametric, so the name of the letter we want to use is t. As t changes, as it gets bigger, it would rotate the point counterclockwise. As t gets smaller, it would rotate the point clockwise. So this radius and this angle are the two things that would affect where that point is. Let's see if we can come up with a formula for the x. What side is side x? Or what position is it relative to the angle which I'm calling t? So get used to the angle being t and not a Greek letter. Yep.
Adjacent.
Adjacent. And what side is r? Yep. Hypotenuse. And what trig function involves adjacent and hypotenuse?
Cosine.
Cosine. So the cosine of my angle, I know it's weird to see the angle as an English letter, but this is how it is in parametric. The cosine of my angle equals x over r. So then what is x?
The radius times the cosine of your angle.
The radius times the cosine of your angle. That's part of the parametric equation you need. That's the x one. Now, the y one is going to be pretty much the same thing. Just think of the trig function we would have to use that would involve the opposite instead of the adjacent. What trig function would involve opposite in hypotenuse? Yeah? Sine. So those are the two functions that you use to draw a circle in parametric. R cosine t is the x, and R sine t is the y. They'll tell you what they want R to be. If they tell you R is 5, you fill in a 5. So now let's find the equation of a circle with a radius of 2. So I want you to take these two formulas and make them specific to having a radius of 2. What would be my x formula if I make the radius 2? Sorry? 2 cosine t. And what would be the y formula if I make my radius 2? Yeah?
2 sine t.
2 sine t. So there's your equations that graph a circle with the center at the origin. Let's try to graph it. So we're going to go make sure you are in parametric. Y equals 2. If you have anything in there, clear it before you start typing. That's the easiest way. Don't try to type over what's already there. Sometimes it messes up. 2 sine t. All right, now we're dealing with sine and cosine. You're dealing with sine and cosine, that means you're dealing with angles. So we have to think a little bit about the parameter. Let's go back to this picture. If this angle doesn't go through enough values, you will not move this point all the way through the different positions in the circle. What angles does t have to go through? So this point would start here and go all the way through every possible location it could be. Yep?
0 to 360.
It has to go 0 to 360. If you don't make this angle go from 0 all the way to 360, you won't make that point go all the way around the circle, and you'll end up with an incomplete circle. So that's the first thing. That's your T min and T max. A lot of times when you're dealing with sine and cosine, it's always 0 to 360. Now, what would be a good value to count by as we go from 0 to 360? Graphing hundreds of points is okay. We don't want to graph like thousands or millions. Yeah? Yeah, I'd say if you count by ones, you're going to get 361 points. That's a lot of points. That should be a pretty good picture. Now, this is a circle centered at the origin, and the radius is 2. So I would say if we go, well, let's go like -3 to 3 and -3 to 3. Now remember, the screen is not a square. So if you go -3 to 3 on both dimensions, it is not going to look circular. It's going to look oval because you're putting the same amount of units on the horizontal and the vertical. But the horizontal and vertical is not the same size on the screen. It's a rectangle. So we can start with that. And I think even graphing 1, counting by 1s, that's probably too much. We can go by 2s and it'll go twice as fast. But you can tell it is a circle. Count the number of tick marks in every direction. 2, 2, 2, 2. It's just the spacing for the X tick marks and the Y tick marks. It's not the same spacing. If you want to make it look circular, well, let's do 2 things. Let's put the T step at 2. So now it'll go twice as fast. And let's do zoom, what is it, 5. Zoom 5 will make the window look proportional. So now things that are supposed to look circular will look circular. And there you go. So there's a circle with a radius of 2 centered at the origin. Now, and that's good. That's what we want. Let's say that I make my t-step go by 90s. What's the first value it would plug in for t and get a point for? Yep. Is 90 my t-min?
Oh no, it'd be 0.
0. And then the next t value?
90.
90. Then
180.
180.
Then 270.
270.
60.
360. You're going to get 5 points. And the 5th point is back where the first one started. So what would happen if you draw a circle with 5 points and the 5th one is back where you started? What do you think it's going to look like? Yeah? Well, it is going to be 4-sided. It's going to look like a square. But yeah. Because you're graphing points at 0, 90, 180, 270. That's not enough points. You need more detail. Even if you went by like 20s, I don't know if that would be enough. It's okay, but I can tell it doesn't look quite as smooth as that other circle. I can see some kind of line segments in there, and that's because you didn't do enough points. Now, besides the fact that this wouldn't look good, what would happen? Well, keep that at 360. What would happen if I go by 50s? I know it's going to look kind of jagged, but we're going to have another problem that we don't want. Declan? Yeah, we're going to have like a remainder. It's going to get to 100, 150, 200, 250, 300, 350, and then it would try to go to 400. So there's going to be a gap between 350 and 360. So we're going to get a shape that not only doesn't look good because of the resolution of our points, but there's this gap here. We don't want that. So pick values that end at the Tmax. Okay, I would say probably the smallest amount you could get away with, and it still looks decent. It looks pretty good if you went by tens. So if you count from 0 to 360 by 10, that's 37 points. Looks good for a circle. Obviously, the bigger the circle, the more points you're going to need. If your radius was 1,000, you're going to need a ton of points because that circle is so huge. All right. Any questions on that one? So, okay, yeah. So when we set our window, the circle only went from -2 to 2 and -2 to 2. But what did the parameter have to go from so we got a full circle? Yeah?
0 to 360.
It had to go 0 to 360. Watch what happens if you don't go 0 to 360. Let's stop at 300. Well, you go all the way around. So if you stop at 300, you're not going to get a full picture. Generally, when sines and cosines are involved, you want to go 0 to 360. Let's try. We'll try one more sketch. I've really shown you pretty much everything. Now it's just practicing setting windows. I think that's the last thing we got. All right, let's try graphing this one. So we want to find a graph of this. So first thing I can do is I can just put my formulas in. T cosine t and t sine t. So t cosine t, t sine t. And what do they tell me they want for the minimum and maximum for the parameter? They do give me that. Yeah?
That's from 0 to 720, right?
It would be 0 to 720. They did specifically tell me in radians, so I'm going to stick with radians. T is an angle. How do I know it's an angle? It's being plugged into a cosine function. If I don't see a degree symbol on the numbers for t in this case, I know it's radians. So that's the first step. Put your calculator in radians. And set your t min and max to go from 0 to 4 pi. Now, in this case, it can be a little hard to get a t max that's going to land exactly at 12.566, or t step. I would say if you step by 0.01, you're going to get pretty close. You're going to get to 12.56. The next one would be 12.57. So you're going to lose 0.006 of your graph, 006370. But if you can get to 12.56, I mean, that's close enough. All right. Now, let's think a little bit about the mins and maxes. Think about just cosine. Forget about t. Just cosine t. If you take the cosine of anything, think about when you graph cosine. Cosine is always between what two values? Doesn't matter if you keep making t go higher and higher. That just makes your graph go further and further to the right. But it's always between what two values, yeah? This is always between -1 and 1. Now, think about t. What do they tell us t is always between? Yeah?
0 to 4 pi.
This is always between 0 and 4 pi. So if you take a number from this box between 0 and 4 pi, and a number from this box between -1 and 1, what's the biggest possible number you could make if you multiply something from this box and something from that box together? What's the biggest result you could ever have? Yeah? 4 pi. Yep. 4 pi is the biggest result that could ever happen if you take something from here and multiply it by something from here. So 4 pi. What's the smallest result that you could get? Yeah? -4 pi. So no matter what happens here, it's always going to be between 4 pi and -4 pi. So -4 pi and 4 pi. And that's exactly the same thing for sine. The highest and lowest that the sine function goes is -1 and 1. And if you take a number between -1 and 1 and multiply it by a number between 0 and 4 pi, you're always going to get a result between -4 pi and +4 pi. So let's set the same thing here. -4 pi, +4 pi. So what we get, 0.01 was too small, but we're getting a spot. And since it goes 0 to 4 pi, that's 2 revolutions of the spiral. And it's picking up steam now. It's going faster. It's probably going faster because it's getting further away from the origin. But we should end up with 2 revolutions. And it won't go off the screen because we checked. But definitely do not use 0.01. That was way too small. But it gives you a good idea of what it looks like. And it's going to end right on the edge of the screen. But it will not go off. So graphing parametrically just takes a little bit of practice to kind of get used to. And that's the end. If something starts graphing forever and you need to stop it because it's taking too long, just press second off and it'll stop. Because if something, like if I put in 0.00001, I mean, that would take hours. So I want to stop it. Okay, let me just adjust this. I guess that's just 1 to 11 odd. We could just simplify it. Okay, any graphing that it says to do, you do not have to do anything by hand. You can do the sketch on the calculator, but please copy the sketch down on a piece of paper so I can see it. So it's 1 through 11 odd, and then 21, 22, 25, and 29 through 32. We'll take a look at that tomorrow.